Welcome back, everyone. Today we are going to talk about implicit differentiation, and that might be a new word for you, the word implicit. And so if we have an explicit, that means that y is defined explicitly as a function of x. And an example of this would be this. This would be explicit versus implicit, which is going to sort of be the opposite. So implicit form would be if we rewrote this function like this. So we have x's and y's kind of mixed together, kind of buried in there together. That's implicit. Now, for this one, we could still get y by itself. That's easy to do, and it would look like this. However, for some functions, it's not easy to do that. In fact, it's actually impossible to do in some cases. All right, so we are going to start out by finding our first function that is not written explicitly, it is written implicitly. And technically, when I take the derivative of this, that's going to be 2x times dx over dx, which is just 1, but I just wanted to sort of show you where that's coming from. Plus, now remember, y is a function of x. That is a big deal. So when I take this derivative, that's going to be 2y times dy dx. Now this turns into a 1 equals 0, of course, because the derivative of 25 is 0. The dx is just 1. So I'm now going to solve for dy dx. I'm going to divide the 2 out. And I'm going to subtract the x and divide the y. And this is going to give me dy dx is equal to negative x over y. Again, I divided out the 2. Subtracted the x and divided by the y to get the dy dx. So here is our dy dx. Here's our first implicit differentiation problem. And part 2 says we want to find the equation of the tangent line at the point 3, 4. Well, m is going to be negative 3 over 4, right? Negative x over y. So there's our slope. And our point slope form is going to be y minus 4 equals negative 3/4 times x minus 3. And let's clean that up a little. And getting a common denominator, that's going to turn that into a 16 over 4. 16 plus 9 is... There is our equation of a line, of the tangent line, specifically at the point 3, 4. All right, next up for example 2, we are going to find the tangent at the point 3, 3. So we're not looking for the equation of the tangent line. We're just looking for the tangent. Actually, this probably, it doesn't say exactly, but this probably does mean the tangent line. So we'll go ahead and finish that. Now, I want to point out here is an issue. Here, I have to use the product rule. So we get 3x squared. Dx over dx is just 1. I'm not going to write that anymore like I did up here. Plus 3y squared, y prime, equals, this becomes 6 times y plus xy prime. Derivative of the x times y is there. X times the derivative of the y is right there. So now I have two y primes, and now I need to dig out the y prime. 3x squared. So what I'm going to do is I'm going to move the y primes to the left and the non-y primes to the right. Now I'm going to factor out a y prime. And divide. See if I can squeeze that here. All right. So now we need to evaluate that at 3, 3. So let's come back over here. So at 3, 3, y prime is going to be 6 times 3 minus 3 times 3 squared over 3 times 3 squared minus 6 times 3. Looks like we might be getting like a -1 situation going on here. This is 18 minus 27 over 27 minus 18, and that is just going to give us -1, which is our slope. So y minus 3 equals -1 times x minus 3. Y equals -x plus 3 plus 3 is 6. There we are. All right. Example 3. Find y prime if the sine of x plus y equals y squared cosine x. Once again, I'm going to have to use product rule here. I just recently taught Calc 1, and in that class, a lot of students missed that you have to do the full-on product rule with this here. So really pay attention to that, please. So I'm going to take the derivative of this. That's going to be the cosine of x plus y times the derivative of this. This is going to be 1 plus y prime. Derivative of x with respect to x is just 1. Derivative of y with respect to x is just y prime. I'm using the prime notation. If you want to use the Leibniz notation, the dy dx, that's fine. Now the right side is going to be the product rule. 2y y prime cosine x plus y squared negative sine x. Okay, I'm going to distribute here. I'm just going to make that minus. Okay. I think this will work a little bit better. I'm going to move the non-y primes to the left and the y primes to the right. You could go the other way around and it'll be a seemingly different looking answer, but it's actually the same thing. So this is going to give me cosine of x plus y squared sine of x equals 2y y prime cosine x minus y prime cosine of x plus y. And I'm going to factor out a y prime on this side and divide. So I'm going to end up with y prime equals cosine of x plus y squared, that's a y, times the sine of x divided by 2y cosine x minus cosine x plus y. Now, I moved my y primes to the right. If you move them to the left, then it'll be exactly the same, except it'll be negative, 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 and positive, which is the same answer. So both would be equally correct for any teacher. It should be. All right, page 2. All right, let's talk inverse trig functions. And I'm going to derive one of them, and then I'm just going to give you the other 5 inverse trig derivative functions. And you'll definitely see some patterns. So to find inverse sine of x, now I want to point out that that means if I call this theta, then what's happening is I'm going to end up with a triangle with theta, and the opposite is going to be x, and the hypotenuse is going to be 1, because that's x over 1. So to find the missing side, this is going to be the square root of 1 minus x squared. We might need that here in a moment. All right, I am going to rewrite this as the sine of y equals x. And I'm going to do implicit differentiation. Cosine of y, y prime equals 1. Which means y prime equals 1 over the cosine of y. So now we can do the cosine of this. This is going to be 1 over the cosine, which is the adjacent over the hypotenuse. So in other words, the derivative of this is going to be 1 over the square root of 1 minus x squared. Now the cosine is very easy, and this is the only one I'm going to derive. It's the same as the sine, but it's negative. And the reason for that is when you, so this would end up being cosine here. When you take the derivative, you get negative sine, right? And so that's where the extra negative comes in. Tangent. By the way, this one is very important to know. This pops up quite a bit. Cotangent is the same, except it's the negative version of that. Secant is a weird one. And if you want to see the derivation of these, you can find it online. It's not that big of a deal. Very similar to what I did with the triangle here. Now that's absolute value of x times the square root of x squared minus 1. And cosecant inverse is the same, but it's negative. So there are your 6 trig functions. So let's practice a little bit using our new friends. All right. So we'll start here. Now, when we say x, it's whatever the domain is. So in this case, it's going to be x squared minus 1. In this case, it'll be inverse sine and so on. Okay, so this is going to be y prime is going to be 1 over square root of 1 minus x squared minus 1 squared times the derivative of the inside, 2x. So overall, we're there. And I'm just going to stop there. I'm sure you could simplify it if you want. You could FOIL that out and see what you get. All right. Let's do the second one here. Y prime is going to be the derivative of cosine, which is negative sine of the inverse sine, times the derivative of inverse sine, which is 1 over the square root of 1 plus x squared, pardon me, x squared. Now this very nicely cancel out. So if you remember the sign of inverse sine, they're inverses of one another, so they actually cancel each other out. So y prime actually becomes negative x. This whole part here becomes x. All of this just becomes x over the square root of 1 minus x squared. All right, and for this last one, actually, I'm going to try to at least keep the inverse secant derivative here. Okay, so this g prime, m, my slope, g prime, is going to be 1 over, now be careful, the absolute value of 2x times the square root of 2x squared minus 1. Which means this becomes 1 over the absolute value of 2x times the square root of 4x squared minus 1. A lot of students forget to square that 2 to become a 4 there. So just be extra careful if you could. Now let's answer this now at x equals 1. Here's my 1 here. So this becomes 1 over now this is absolute value of 2, which is just 2. So 1 over 2 times the square root. Now 1 squared is 1 times 4 is 4. 4 minus 1 is 3. So here's my slope. 1 over 2 root 3. So we end up with y minus pi over 3 equals 1 over 2 root 3 times x minus 1. And let's try to clean that up a little. And believe it or not, that is the whole thing. You could get a common denominator there, I suppose, but there's really no need for that. I hope that was helpful.